Well, good afternoon, everybody. I'm Simon Patton from EMQN. I'm one of your co-chairs for today's webinar. So this is a non-promotional master's class organised and funded by AstraZeneca, and we're going to be talking about ensuring accurate classification of HRR variants. Next slide, please. So just a few housekeeping rules, please. We've already got 150 or so participants dialed in. So the key rule, if you like, first of all, is please ensure that your microphone is muted. We will automatically mute them, but please don't unmute it until we give the opportunity to be able to do any feedback if necessary at the end of it. The webinar itself is being recorded, and that's primarily so that you are able to then access it after this session has closed. It'll probably take us 10 days to 2 weeks to get through compliance, but we hope to be able to make it available to you and as a good resource and a learning resource for you to be able to help your training with respect to HRR gene variant classification. And most importantly, we really value your feedback. So you can submit your question and answers through the Q&A window, which you can find on the bottom menu bar of the Zoom app. We're not going to do a live Q&A feedback session at the end of the webinar, but what we are going to do is collect all your responses, all your questions, and then add those to the scheme report that we're going to feed back at the end of it. So we collate all the data, and the next webinar, which follows on from the end of the run itself, will actually have much more of an interactive feedback session with a proper live Q&A session. But we think there's more value today in making sure that the really fantastic presentation that's going to be given by our speakers, the educational component is really got through to you guys. So the value for us will be collecting the data from the end of it and feeding back to you in the report itself. So please do submit your questions via the Q&A window at the bottom. Next slide, please. Okay, and also feedback is really important for us. It certainly helps us to improve, and providing these webinars is part of our commitment, if you like, to providing high quality training to all healthcare professionals undertaking this type of activity. So after the masterclass is finished, you will receive a short, an email, should I say, with a link to a short feedback survey. It should only take 2 minutes or so to complete, but we do encourage you, please, to make sure you feedback after the webinar so that we can also learn from the experience. Okay, next slide, please. So without further ado, I'm going to just obviously do the introduction here to say that we have a fantastic group of speakers for you today. Experts in this field have got stacks and stacks of experience in variant classification. We have speakers from Ghent, so Kathleen Claes, from Alberta in Canada, Andrew Muranyi, and last but not least, from Dublin in Ireland, Dr.Trudi McDevitt, and myself and my co-chair, Prof.Sandi Deans from GenQA, are chairing this meeting, this webinar for you. So I think that's one last slide to do. So thank you very much. So that obviously our disclaimers and disclosures, and I'll hand over to my co-chair, Sandi Deans.
Thank you, Simon. So next slide, please. Okay. So just to add my welcome to Simon's, and thank you for joining the webinar. There's been a question in the chat already, just to clarify. So yes, you will be able to access this recording after today. And as Simon says, it may take up to 2 weeks to go through compliance, but we will definitely send the link out as soon as we're able to do so. So I will just give a very quick outline of the aims of the webinar today, and then the second subsequent follow-up webinar, which will take place on the 8th of December. So it's about providing these educational webinars to promote accurate classification of HRR gene variants. Now, we've run previous masterclasses and similar webinars, predominantly focusing on BRCA1 and BRCA2 gene variants, but we're now extending that on the back of a successful run last year, and we're looking at different HRR genes as well as BRCA1, BRCA2. So today we have our expert panel that Simon has introduced, and we're going to start talking about best practice guidance, what's available for us, and what other resources can be used. And then, which is always incredibly useful, is actually to see the guidance and the documentation being used in action. And our panel is going to go through 6 different variants and work through the examples and what evidence is being used and why that classification has come about. Now, to sort of evidence your education and demonstrate the competency in this area, there is now a GTAC online training and competency tool, which will be open after today. We currently have 357 participants registered, so I'd encourage you, if you're on the webinar today and would like to participate, then please do so, and we'll give you details of how to do that shortly. Participation is open to everyone as it's funded through an AstraZeneca and Merck educational grant, and it really is a benefit for you yourself. It's not a laboratory-based exercise, it's about you, so you can use it for participation and demonstrating of your continual professional development or your continuing medical education. You will be asked to classify 6 HRR gene variants and summarise the criteria used. And this information then will be generated and collated, so you get your own feedback score report back to yourself that can be downloaded from the website. And also we'll collate an overarching EQA summary report, whereby you can see the results from all participants plus the expert panel review. We will present this on the second webinar in December and give you a summary of the EQA outcomes. So when you log into your assessment online, you'll be able to download your submission. So when it comes to the second webinar, you will have to hand what you actually submitted yourself. And then we will have a live Q&A session during that webinar. And just to say, any questions that are submitted today through the Q&A and also in December, we will have a written response to those in the EQA summary report as well. Next slide, please. So the objectives really for these webinars and the EQA exercise is to really give an overview of the framework to classify variants. And HRR genes and BRCA sometimes are classified in different ways than other gene variants, and it's important that we have these focused webinars to be able to specifically drill down to the evidence and the guidelines that are available to us. Also, we want to outline the mechanism of classifying somatic variants according to guidelines. And as I said, we highlight the specific resources to these genes that we're looking at today. And as I just previously mentioned, it's always incredibly useful to see worked examples rather than just educational and a lecture facility, but actually to see them in action in the real world. Next slide, please. So I've got great pleasure now to hand over to Kathleen, who is going to give you a summary and an educational elements of the best practice guidelines for us. Thank you, Kathleen.
Okay, good afternoon. Thank you very much for the nice introduction, Sandy and Simon. I will first give an introduction about the BRCA genes and HRR gene variant classification and the best practice guidelines that are available. So next slide, please. Yeah, okay. So to start with, I would like to present you here the HRR gene pathway. As you know, DNA double-strand breaks are amongst the most threatening variations that can occur in the genome, and they will really affect the genome integrity. So they need to be repaired. To do this, the cells have different pathways available. So we have the classical non-homologous end joining pathway, the single-strand annealing pathway, and the homologous recombination pathway. However, the choice is a bit dependent on the cell cycle. So you see here that the classical non-homologous end joining pathway is mainly active during GN phase of the cell cycle, but it can also act throughout other moments of the cell cycle, but most prominently during the G1 phase of the cell cycle. It starts with phosphorylation of 53BP1, and then it's important, the non-homologous end joining, it will directly seal broken ends, but the repair product is often accompanied by sequence alteration, so it's inaccurate. Same counts for the single-strand annealing pathway, which occurs during M phase of the cell cycle when the end joining pathway and HRR pathway are not active. However, also here, this pathway uses homologous repeats to bridge DNA double-strand breaks, and also this leads to large rearrangements, including deletions and translocations. So it's also a very inaccurate pathway. Today's focus is, however, on this pathway, the HRR pathway, where it starts with an activation of BRCA1 that will result in PALB2 BRCA2 mediated double-strand end resection to single-strand DNA, and then the replication protein A and the RAT51 will anneal, and DNA double-strand breaks are repaired using the homologous region of the sister chromatid as a repair template, as a replicative template. So this can only occur during late S and G2 phase of the cell cycle, because these sister chromatid needs to be available. And this pathway is important not only because many of these genes are associated with an increased risk for breast and ovarian cancer, but also, of course, they can be targets of therapeutic interventions. What kind of variants can we find now in BRCA1, 2, and the other HRR genes? So you can have missense variants when there is a substitution of one nucleotide that results in a change to another amino acid. Frameshift variants, when you have a deletion or insertion of a number of nucleotides that's not multiple of 3, then you see, for instance, an example here where the C is deleted, and so you get then a frameshift within your protein sequence. And there are the nonsense variants. The nonsense variants whereby only one nucleotide is changed, and due to this, a stop codon is introduced. And of course, there are also larger rearrangements that may affect one exon or multiple exons, and that can also have a pathogenic effect. How do we classify now the variants? Well, when I started my PhD more than 20 years ago, at that time I was taught that there were mutations and polymorphisms. However, this has changed over the time because this terminology can be confusing. So to really establish if a variant is causal role for the disease or is pathogenic, there are several parameters that can be taken into account. And since then, I think the first publication dates back from 2008 from IRC, where they propose to use a 5-class system, whereby class 4 and class 5 are the variants that are pathogenic or likely pathogenic. So this may respectively be consistent or confirming the diagnosis. And these can be used in the clinics to test at-risk relatives for the variant, or to provide full high risk, and these patients or relatives that have this variant should follow the full high risk surveillance guidelines. Just want to show that the border of the risk assessment has also changed a bit. So in the first publication, it was more than 95% chance of being pathogenic, while this was now in the more recent ACMG and ACGS guidelines reduced to more than 90% chance of being pathogenic. On the other end of the spectrum, we have the non-pathogenic variants, so the not pathogenic or the benign variants and the likely benign variants. And then there is a large gray zone in between. It's the class 3 variants, which are of uncertain pathogenicity, and they do not confirm or exclude the diagnosis. So these 3 last classes cannot be used for predictive testing in at-risk relatives. And if you want to give advice to the patients on surveillance, it should be based on family history and other risk factors. So the easiest variants to classify are the variants that are definitely pathogenic, and these are clearly all loss of function variants, like truncating variants, splicing variants, large rearrangement deletions, and missense variants in some specific functional domains. However, for each rule, there are exceptions, and the best known exceptions are, of course, in BRCA1 and 2, because this must be the most studied genes worldwide, where we, for which several detailed limitations are being published. I will not go into detail about this because it's a bit beyond the scope of this webinar, but there is an international consortium that has published detailed guidelines specifically for BRCA1 and 2. What about the unclassified variants, the class 3 variants? Well, what is a definition? Is a variation in a genetic sequence whose association with disease risk is uncertain, and a bit dependent on the country where you live. There might be different abbreviations used. So you can talk about UVs, FUS or VUS. And variants of uncertain significance, of variants of unknown significance. And of course, this is a large burden for the people who have to report it in the labs, but also for the clinicians and the patients who receive these gray zone results. And that's why it's important that we classify all the variants according to, with guidelines, and that we use all similar guidelines to make sure that when a patient is tested in lab A, receives a similar interpretation as a patient with the same variant tested in a lab B. And in 2015, ACMG has published its first set of guidelines, which are still used a lot. And I think also for the participants to this webinar, these are the most frequently used guidelines. In the meantime, several criteria have been further refined from these ACMG guidelines. So there are several papers to be found to give more details about some parameters that can be applied. Also in UK, they have, specifically for UK, they have developed own the guidelines. And although I'm not based in UK, I really like them because they really are helpful to interpret some of the parameters that are a bit vague in the ACMG guidelines. Also important to know as background is that I've been talking about the 5-class system to classify the variants. This is mainly used for the interpretation of the germline variants. In the somatic field, they often work only with 4 clinical classes. So they make a distinction between the biological classes, the 5 biological classes, versus the 4 clinical classes, where, of course, the focus is not really to find variants associated with increased risk, but variants that may impact the therapy. And so they have variants of strong clinical significance, potential clinical significance, unknown clinical significance, and unbenign or likely likely benign variants. So they take together the two lowest classes. I am aware of specific Belgian guidelines related to that, how to standardize this for the labs offering somatic testing. This is what I want to show for the Enigma guidelines. They are only for classification of variants in BRCA1 and 2. The latest version already dates back from 2017. And these guidelines are specifically for the variants with a high risk. In the meantime, the Enigma consortium is working together with people from ClinGen to establish new guidelines because here the Enigma did not use the same parameters as ACMG, and they are now updating their guidelines to make them uniform to other generally accepted guidelines. So maybe good to know that in the coming months we are expecting the new version for BRCA1/2. So coming back to the ACMG guidelines, the publication from 2015, there were proposed 28 criteria which cover a variety of evidence, and they were mainly based on population data, functional data, segregation studies, de novo observations, allelic data, as looking if there are pathogenic variant on another allele that may help you to interpret the variant you identified, and also the use of computational predictions. Also, it's very important to be cautious that you do not use the same piece of information twice. So for instance, if you evaluate splicing, if you have RNA data available, then you should maybe not combine it with in silico predictions. And there are then several criteria that can be used as evidence for pathogenicity and criteria for benignicity. You have, it's subdivided in criteria which are very strong, moderate, and supporting. For the benign variants, you don't have the moderate level. So here you have a bit an overview on some data, well, the strength of some of the criteria, for instance, and the variation you can have. So for instance, for the population data, you can have benign standing alone. This is used for variants that are occurring very frequently in population databases. So, and with very frequent, we mean generally more than 1%, then we can use it as a standalone criterion to determine that this variant is benign. Yeah. You also have variants that are where you feel that they are too frequent to mean something, and then you can distinguish between BS1 and BS2. And variants that are very rare, for instance, can have a strong or a moderate, can fulfill the criteria for strong or moderate. And so there are different criteria for the different parameters that can be evaluated. So, and then if you take all the criteria together, based on that, you can determine if a variant is pathogenic or likely pathogenic, or on the other side of the spectrum, benign or likely benign. So for instance, if for it to be pathogenic, you can have one very strong argument and one strong or one moderate, or more than two or more supporting evidence criteria. And so that's what is summarized here. I still do not know this by heart. I still have a table on my desk, a printed table on my desk to quickly look this up to be able to use it. The disadvantage of this kind of criteria if there is insufficient evidence to reach a conclusion of, and especially if there is conflicting evidence, then you always will end in a variant of uncertain significance. And this means in practice that you might end up with a lot of variants of uncertain significance. And this is also can also be attributed to the fact that these criteria were formulated with rare diseases in mind, rare diseases with rare phenotypes. Of course, this is not the case for the variants we are studying in the HRR genes, because they lead to breast or ovarian cancer or prostate or pancreatic cancer, which are also quite frequent in a general population. We can also not use de novo status for many of these genes, and also the criteria were also not formulated to take into account reduced penetrance or non-penetrance in, for instance, male relatives. So that makes it sometimes difficult to do reliable interpretations. And yeah, also we often do not have large families available for segregation analysis. So these are a bit the disadvantage, the limitations of the ACMG criteria, and why we cannot come to final conclusions. And this is one of the issues that the Cancer Variant Interpretation Group from UK, CANVIC, has tried to solve. And that's why they have published specific guidelines for cancer susceptibility genes. And I think the first version was published last year in 2022, which can be used in conjunction with the ACGS guidelines. And it gives you more support to know when you can use a piece of evidence as very strong, moderate, or supporting. So I'm happy to hand over the work to Trudi. She will explain in more detail the CANVIC guidelines.
Okay, thank you very much, Kathleen. So as Kathleen mentioned, the ACMG guidelines don't apply in all aspects to the cancer susceptibility genes due to the common phenotype and variable penetrance associated with those genes. So the CANVIC group was established in 2017 to work with the ACGS guidelines and within the ACMG framework to develop guidelines to help laboratories in a practical way to apply evidence criteria for the cancer susceptibility genes. And as Kathleen stated, the first guidelines were released in 2020. And associated with this is a really helpful website that's open to all, that allows access to various resources where there are really good presentations explaining the use of some of the evidence criteria. There are functional studies scoring, whereby functional studies are assessed via the Wernicke criteria, and then the evidence, the information is put there so that you can go in there and see which functional studies are validated for use and at what strength they can be used. There's also the variant database, the CANVAR UK variant database. It's a data sharing initiative that was started by within this forum, whereby, I mean, currently most of the information there is for BRCA1 and 2, but the Lynch syndrome genes are also increasing in number. Currently, there's nearly 30,000 entries in this database, and it's really helpful for looking at case control analysis and use of PS4, and it allows the use of PS4 at different strengths. So it's live, so if people have more information on a variant, they can deposit it on the database for everybody to see. So that's really helpful. So next slide, please. So this year actually, just after Run 6, these guidelines were updated. And so some of the changes include the introduction of this point system here, which is a move towards a more kind of Bayesian quantification system for assessing evidence strength. And I think there's more information coming out on updated guidelines in 2022 from the ACGS and CANVIG. So, and indeed, specifically for BRCA1 and 2, in the updates for this year, the likelihood ratio scores from multifactorial analysis studies can now be incorporated in a more appropriate way, given how good this evidence is, for use with PP5 and BP6, so that these can now be used at variable strengths, whereas previously this evidence couldn't really be incorporated. So next slide, please. Some changes to the guidelines, some updates are further information for pathogenicity for the variants list, for the criteria listed here, and also for benignity, and they're grayed out in the publication so you can see additional information. And for example, you can see PVS1 from the 2020 guidelines, how much more information there is available for PVS1 in the updated 2021 guidelines. Another change includes the organizing of the evidence criteria into themes. So grouping them according to whether they address population data, computational data, functional data, and so on. And this helps also with thinking about what evidence criteria can be used together to be careful about double counting. So next slide, please. Further to this, there is information to help participants with assessing what evidence criteria can be used together by a graph of combinations towards pathogenicity and towards benignity. So for example, you can see on the pathogenicity one that PM1 can now cannot be used with PM5. So they are contraindicated by this red here. They can't be used together because it's considered as double counting and against the Bayesian dogma of only using a piece of evidence once. So next slide, please. Another bit of evidence that's been expanded is the functional data evidence. There's more information on this. There's a link to the functional studies that have been assessed by Bernick, and it brings you to this table where you can look down at the various functional studies and see that if you, whether you can use it for PS3 or BS3 at a strong or moderate level. There's also advice or information guidance on what to do if functional studies are conflicting. By these two tables here, you can see if you have assay 1 and assay 2, you can see whether, depending on the type of assay it is, whether you can't use the functional data at all, or whether you can, depending on the what the functional data gives you for assay 1 and assay 2. So that's helpful as well. So next slide, please. So this scheme for Run 7 is a non-BRCA1/2 HRR scheme, but we thought it would be useful to go through some of the variants in Run 6 because they do highlight some learning points that would be useful for the HRR Run 7 scheme, and also they highlight some points from the some changes, implications of changes from the updating of the guidelines, the CANVIG guidelines. So next slide, please. So starting with variant 1, next slide. This variant is a splice site variant in BRCA1 where the prior risk of pathogenicity is unknown. Next slide. So it's there's information from the multifactorial analysis studies indicating benign. It's present in NOMAD 13 cases on the non-cancer females. Next slide, please. So there's no evidence favouring pathogenicity, but in support of benign, there's BS3 strong because multiple splicing assays indicate no effect on splicing. And these are two studies that are indicated on the CANVIG website as being validated for use at a strong level for both PS3 and BS3. So we can immediately assign BS3 to this variant. BP6 supporting was assigned based on the multifactorial analysis data that's out there reporting the variant as benign. So based on these two bits of evidence, we get a likely benign for this variant. So next slide, please. So the returns for this, we're expecting a class 2 most participants returned a class 1, likely based on the multifactorial evidence that's there. There were 13 cases on NOMAD, so some participants used PM2 or BS1 for this. PM2 would not be appropriate because it's only if you've got 1 or 0 cases on NOMAD that you can use PM2. For BS1, I'll just talk about that a little bit more in the following slide. As Kathleen mentioned, BP4 and BS3 are contraindicated because they're counting the same bit of evidence based on splicing. BS2 would not be so applied to the BRCA genes because of the penetrance and the fact that it's a common disease. Now, BP6 was the main reason for the difference between class 1 and 2, and it's due to the use of BP6 at variable strengths by participants. So at the time of the original, at the time of Run 6, the CAN-VIG guidelines 2020 allowed BP6 only to be used at a supporting level, even if you had multifactorial evidence there. But now with the new guidelines, you can incorporate the likelihood ratio scores from these studies to be able to use BP6 at various levels. And using this likelihood ratios allows BP6 to be used at a strong level now. So therefore you would have 2 strong bits of evidence, and this variant would now be classed as a benign variant. So next slide, please. Just talking about BS1 a little bit more, a lot of labs had used BS1 based on the fact that there were 13 cases in NOMAD. So for BRCA1 and 2, it's helpful to use this CardioDB tool. And there's a good presentation on this in the CanGene website by Miranda Durkee. And using this tool, it tells you that the maximum tolerated allele count is 18 cases on NOMAD. So therefore, in this case, BS1 wouldn't apply. Now, you can't always use this CardioDB tool. It's not really, it doesn't work very well if there are, if the gene has a much lower frequency prevalence in the disorder. So it's good for BRCA1 and 2. So next slide, please. So classification with variant 2, next slide, please. Variant 2 is a missense variant where the prior risk of pathogenicity is unknown. Next slide, please. And the evidence is as shown here. So again, multifactorial analysis rates it as a VUS. Next slide, please. The evidence that we were able to get together was a PM2 moderate, PM1 supporting, PP3 supporting for a REBEL score of 0.86, and PM5 supporting for this variant in the same position, same amino acid residue, which has been widely reported as pathogenic and supported by multiple functional studies that are in agreement for that variant. So we obtained a VUS class 3 for this variant. Next slide, please. Participant returns agreed mostly with a class 3, and there were some class 4 returns. So implications from the updating the guidelines since Run 6 came out was that PM1 and PM5 cannot be used together. And in addition, PM5, which is the evidence you assign for the similar variant being reported as pathogenic, this criteria can now not be used if your functional studies are conflicting. So therefore, with the change in the guidelines, you'd be able to use PM1 now at moderate based on the Enigma assignment of this variant being a critical variant in the BRCT domain. So you'd have PM1 moderate, you'd have PM2 moderate, you would not have PM5, you would have PP3. In addition, using the likelihood ratio scores for this variant from the Parsons paper, it would actually allow you to use BP6 at a strong level. So that's another bit of evidence you would have. It's a conflicting bit of evidence, so this variant would remain as a VUS based on conflicting pathogenicity and benignity evidence. Next slide, please. So variant 3, next slide, please. This variant is a frame shift variant. but the prior risk of pathogenicity is unknown because it's in the last exon of BRCA1. Next slide, please. So there's very little evidence that we could use from these resources. Next slide, please. The evidence that we did use was a PVS1 moderate and a PM2 moderate for not being on the NOMAD database. So we get a class 3. Next slide, please. The expected outcome was a class 3, but most participants returned either class 4 or class 5 in fairly equal distribution. PM4, PP3, and PP1 were all used by various individuals, but they would not be applicable in this case because the variant is a frame shift. The biggest difference, the biggest reason for class 4 and class 5 was the use of PVS1 with different strengths, ranging from strong and very strong. So next slide, please. So looking at PVS1 in a bit more detail, there's a lot of information on the new guidelines for use of PVS1, and it's all around the use of the Abu Tayoun PVS1 tree. So if we follow this tree for this variant, the variant is in the last exon of BRCA1, so therefore nonsense-mediated decay is not predicted. And to help with this, the Decipher site is really helpful because it highlights the area of where NMD is not predicted in the gene. There is not a stop codon created within the 3' UTR region of this gene. So therefore, non-stop mediated decay is also not predicted. And so we expect full length, intact protein with an additional 58 amino acids on the end and disrupted last 10 amino acids of the gene. So just going through the tree there, the variant is a frame shift. It's not predicted to undergo nonsense-mediated decay. So now we need to assess the role of the region in the protein. What's the function? So one way to do this is to look at amino acids in the same region and also downstream. And we can do this by looking at a validated functional assay like the Findlay assay. And using this, we can see that amino acid missense variant at the position and also downstream do not alter the function, are not predicted to alter the function of the protein from the wild type. So therefore, we have to assume that the role of the protein is unknown. The variant is just beyond the region, the critical BRCT region. Loss of function variants in the exon are not frequent in the general population, and this exon is present in biologically relevant transcripts. The variant removes or disrupts less than 10% of the protein. It's just the last 10 amino acids of the BRCA1 protein that are disrupted. So therefore, we get a PVS1 or moderate for this variant. So that's just an overview of 3 of the BRCA variants from Run 6. Just highlighting some of the changes from the updating of the guidelines, and just may be helpful for some of the HRR genes in Run 7. And now I'd like to hand you over to Andrew.
Thank you, Trudy. So I'm going to go over some examples from the HRR genes from Run 5. These are non-BRCA related. Apologize. Not sure why the slide. Oh, here we go. So variant 4. This is a RAD51C variant. It's a missense variant that changes the leucine to a phenylalanine at amino acid 138. It's a missense variant, and it's in the ATP binding domain of the protein. So in ClinVar, 5 labs classified this as either likely pathogenic or pathogenic. In LOVD, it's predicted to affect function. One allele was found in the NOMAD database. It had a Revel score of 0.592. and SIFT and polyphen predict it to be deleterious. This is an example of a variant where we actually do have segregation information. There are 2 large pedigrees published looking at this variant. So we were able to use PP1, so evidence for segregation on this variant. I know often is the case you can't find this type of information, but for this particular variant, it was present. There are also several functional assays. They cited 3 here, but I think there were 5 last time I checked, showing in various different assays that the function of the protein was disrupted. So for this variant, we can use PS4 moderate, as this is prevalent in affected individuals, so significantly more than in the general population, the controls. Also PS3 moderate, the in vitro and in vivo functional studies support damaging. We can also use PP1 as for the segregation data based on the 2 large pedigrees. I apologize, there's a typo here. This shouldn't be very strong. I believe it's meant to be moderate. There's also PP3, the in silico evidence supporting deleterious, and PM2, as there was only 1 allele in the NOMAD database. There was 1 piece of evidence favoring benign, and that would be BP1, a missense variant in a gene for which primarily truncating variants are known to cause disease. So when you add this up, you get a prediction class of class 4, or likely pathogenic. So the majority of people who submitted this variant got the expected class 4. However, there was also a large population that got to class 5. And this was primarily based on using PS1 and PP2, so that those 2 pieces of evidence seem to be the 2 key pieces of evidence that separated classifying this variant as class 4, which is what we predicted, versus class 5. So the second variant I'm going to go over, which is the 5th variant, is a PALB2 variant. It's C.2506 G to A, which changes a valine at amino acid 836 to an isoleucine. And this affects the RAD51 binding domain. So this variant is present in ClinVar, but it's conflicting in the evidence towards whether it's a VUS or likely benign. LOVD has it as a VUS. There are 3 alleles in the NOMAD database, and this has a Rebel score of 0.02, and it is tolerated in SIFT polyphen and aligned GVGD. There are no publications, or at least at the time of this scheme, there were no publications on this variant, and there are no published functional assays for this variant. So this is a case of one of these variants where there's very little information. You can use PM2 in that there are very few alleles in the NOMAD database. And you can use BP1 because this is a missense variant in a gene where primarily truncating variants cause disease, and BP4 based on the computational or in silico evidence, which you get to class 3, variant of uncertain significance. This is a common finding for variants where there's very little information. You just don't have enough information to classify the variant in one direction or another, and they end up quite often being variants of uncertain significance or class 3. And the majority of individuals who submitted this variant also classified this variant as class 3. So the last variant I'm going to go over with you is the ATM C.1898 plus 2 T to G. This is one of the canonical, it's present in one of the canonical splice sites. ClinVar has 7 classifications, 7 labs classifying this as likely pathogenic or pathogenic. LOVD classifies this as affecting function. There is only one allele present in the NOMAD database, and in silico splice predictions predict that a splice donor site is abolished. So using the PVS1 decision tree, we're able to use this information as PVS1 very strong. It's also, we could use PM2 in that it is a low frequency in the NOMAD database. In silico supports deleterious, and PS4 is used as moderate evidence, as the prevalence of the variants in infected individuals is significantly increased compared to the controls. So PVS1 very strong, PM2 moderate, PP3 and PM4 give you a class 5 or pathogenic prediction. And once again, the majority of individuals classified this as being pathogenic, with a small number also classifying it as likely pathogenic. And so that's the end of the examples.
Thank you, Andrew. I'll pass over to me now then. So just to clarify that we will open the GTAP variant classification exercise for the external quality assessment, which is now run 7. Can you believe we've done 6 previous runs? It's fantastic. So next slide, please. So the instructions to register for participation, if you've not already done so, is this website here, and we will put this information on both GenQA website and EMQN, so you know where to get that detail from. And once your registration has been confirmed, you'll receive instructions on how to log in. The EQA will be open from today to the 26th of November, and to participate, you just go to the genqa.org website and log into GTAC. There's a button there that takes you straight through, and you can complete your variant classifications. And hopefully the educational and the presentations that you've just heard will help you tremendously to tailor your evidence-based classifications. So you submit details of the criteria that you've applied for these specific variants, and then, as I mentioned earlier, you can download your own report of your submissions. So when you join the second webinar in December, you'll have a note of what you have submitted, and you can make comparisons there and then. So we do invite you to join the webinar on the 8th of December, and we'll have an expert review of our actual run 7 variants then, and give you an opportunity to ask questions in the live Q&A session. So you just log into your GTAC account to download your assessed report and participation certificate and the EQA summary report after the second webinar. So next slide, please. So just remains to say thank you very much indeed. Simon, do you want to take a couple of questions? I see we do have quite a few in the chat. Maybe we can do some just guidelines ones before we end, and we can add all of the feedback into the EQA summary report later on.
Yeah, thank you, Sandi. So I'm just triaging through the questions just to find something that's we can deal with in this feedback session. I think we could probably just get some feedback from the panelists on the first question, which comes on the use of ACGS best practice guidelines. So I think probably Trudi might be the best person to answer this. So I use ACGS best practice guidelines for variant classification, the 2019 and the 2020 versions, and by combining criteria of ACGS, but the combining criteria of ACMG, should I say, of 2015. Is it wrong to do this? Should we be using the combined criteria of 2020? Trudi, are you able to just give a quick summary again of using the combinations of the different guidance for respect to this question?
I think they're probably referring to the updated table in the ACGS 2020 guidelines. So in that case, they were modified based on the Tavtigian Bayesian paper in 2018, where there was found to be some discrepancies in the in the grading, the evidence strength. So it's the table in the 2020 guidelines that should be referred to for the pathogenicity combinations. Does that make sense?
Yeah, it does. And so, as I said before, when we started this, the feedbacks, well, the webinar, we will, as I say, get back to the participants with a more in-depth response to all of these questions.
Yeah, I think there is a good explanation in the ACGS 2020 guidelines ahead of that table to explain the difference.
Yeah. Sandy, would you like to pick another question?
Yeah, I'm just looking down. A lot of them are about the specific variants that we've been talking here. Although there does seem to be a trend about the use of PS4.
Yep.
Yeah, so more sort of generic, and we will come back to you with specific question feedback, but where do you get the data to support the use of PS4, and which guidelines help in determining the strength of PS4? Any initial thoughts from the panel?
I suppose for BRCA1 and 2, it's fairly easy if you use the the CanVig website and the data from the UK labs to use PS4. But if the variant hasn't been reported there, the other source is to look at the literature and see what cases have been reported there, sort of specific literature reports of cases, but looking at the phenotype. Carefully make sure that it's a true case. And then I think then you can use the ACMG guidelines so that there's by case counting, sort of there's 2 or more cases, you can use PS4 at a moderate level.
Thank you, Trudi. So moving on from that, someone else has asked about advice how to use PS4 with ClinVar and publication case counts. So for example, a variant's listed 4 times as a VUS in ClinVar and no case in Nomad. Can I use PS4?
We wouldn't generally use PS4 in those circumstances because you can't dig down and evaluate the data and determine the phenotype that's behind those cases.
Great, yeah, thank you. So that hopefully that's helped to clarify. There are some other specific queries on PS4, but as I say, we'll come back to those specifically.
Yeah, looking at the questions, Sandy, I mean, a lot of them are very specific to the particular variants we've talked about in the already in the webinar itself.
Yeah.
So I think
I was going to say, sorry to interrupt. I did notice one question there that's probably very quickly answered is the use of PS3 with PP3. It's one that comes up quite a lot because in the in my variants there, we couldn't use the BP4 with BS3 for the splicing. But there's a difference in using the splicing in silico with the splicing functional compared to using the protein-based in silico with the protein-based functional. So those you can use the PP3 with PS3 and BS3, but you can't use BP4 with BS3 and PS3.
Great. So, and I think we'll put that, that's very complicated, isn't it? So I think we'll put that in writing, but basically it's about avoiding double use of the same evidence, isn't it?
For the splicing, but the protein-based function is okay, yeah.
It's separate, yeah, absolutely. Thank you, Trudi. Okay, I think we'll finish there, Simon. I think that's a huge amount of interesting information. I know my head's spinning, so I look forward to the EQA and the next webinar.
Yes, a big thank you, obviously, to you, the participants, as well, for dialing in. It's great to have so many people dialed in again today, so over 200 again. We really look forward to you joining us in the actual EQA exercise itself, and as Sandy said, to our next webinar, which is in early December, where we really do hope to have a really good live Q&A session for you. On the results of the EQA itself. So I think it just remains for me to say thank you very much to everybody else involved, including the production team as well, and the guys at AstraZeneca. And lastly but not least, my co-chair and most importantly, the speakers from today. So a big thank you to them particularly for presenting such a great webinar. And we look forward to catching up with you again early in December.